In today's section, we're going to be talking about nonlinear inequalities and system of inequalities. We're going to be taking a look basically at the conic graphs we've done in sections 1 and sections 2, and we're going to add some inequality features to it. You might recall we did this quite a bit when we looked at linear lines. What we did with linear lines is we would have an equation, but instead of an equals, we would have an inequality. Less than, greater than, less than or equal to, and so on. And what we would do is we would graph the equation version of it on a graph. So -4, and then up 3 over 1 for the slope. And depending on if it was less than or equal to, it would be a solid or dashed line. So we would do a dashed line in this case. And there were two things we talked about. One was testing a point. What we could do is we saw that this was divided into two halves, above the line and below the line. So what we could do is we could test a point. So if I tested 0, 0 into the inequality, we would see that 0 is not less than -4. So this side would be false and therefore shade the other side because the other side would have to be true. We're going to do something very similar when we talk about graphing the inequalities of conics. What we're going to do is we're going to graph the equation version of the conic, and then we're going to test a section to see which part of the conic we're going to shade. So the first one we're going to do is x squared over 25 plus y squared over 4 is greater than or equal to 1. You can tell by the equation that this is going to be an ellipse. We know this because both the x and the y are squared, and you can see that the denominators are not equal. Now this will be a horizontal ellipse because the bigger number is underneath the x. So the major axis is going to have a total of 10, and that's because it will be 5 units on each side. And then the minor will have a total length of 4 because, again, 2 on each side. The center will be at 0, 0. So let's go ahead and graph that ellipse. You can pause the video and graph it. So I went ahead and I graphed that ellipse right there. Because this is a greater than or equal to, you'll notice that I kept it a solid ellipse, so it wasn't dashed. Now what I'm going to do is I'm going to pick a point, and you'll notice instead of a line being, dividing the graph into two with a straight line, it divides the graph into two again, but it's different. You'll see that there is the part inside the ellipse, and then there's the part obviously on the outside of it. So those are the two parts that we're going to work with. What we're going to do is we're going to test a point. We're going to test 0, 0. And we'll put that in the equation. 0 squared over 25 plus 0 squared over 4, and we're going to see if that's greater than or equal to 1. 0 is not greater than or equal to 1, so this is false. So we are going to shade on the outside. And that's really the main part to this lesson, is just making sure you're shading the inequalities appropriately once you have the graph drawn. The next example we're going to see is 9x squared is greater than 4y squared plus 44. What we're going to do with this one is we're going to subtract the 4y squared, and that will be greater than 144. We'll divide both sides by 144, sending it equal to 1, and you're going to see that this is a hyperbola. Go ahead and graph the hyperbola. Go ahead and pause it and graph it, and then resume it to see if your hyperbola matches what you'll see on the screen. You can see my work on the left to put it into that hyperbola format that we usually like. You can see that's a hyperbola because it's a subtraction right here, and both the x and the y are squared. And then I have the drawing on the right to kind of show the boxes and the asymptotes that you see with the diagonals. If you test 0, 0 right here, you have 0 over 9, which is 0, minus 0 over 36, which is 0. And that is not greater than 1, so that is false. So since this area is false than the outside of it. And unlike a linear line or with the ellipse that we saw in the first example, you'll notice that there are actually three sections. There's the inside of the parabola, and then there is the outside. So either the inside will be true or false, and the outside will be true or false. They kind of go, the outsides get paired together. But again, since it was false in the middle, we'll take away that, and we're going to show you the outside. You'll also maybe notice that the red line of the hyperbola is dotted, and that's because it is a greater than sign. And our last example for the day is graphing a system. Basically, you're graphing more than one graph on one coordinate plane together, and you're seeing where the overlap is. So we have a parabola, y is greater than x squared, and then we also have a linear line, y is less than or equal to negative 4x plus 2. Again, go ahead, pause the video, graphing both of these, and then restart it to see if it matches up. So here you can see the parabola and the linear line with the shading. You'll notice that where they overlap with the yellow and the blue forms a green. Now, if we zoom in, or maybe that's a zoom, there we go. The area in the green is actually the solution area. So this straight line that intersects this parabola, so the solution area refers to that green part. The yellow is not part because it doesn't have both the overlap, and neither is the blue, so just that little part in the middle.